Let's do an example where we find the center of an area, also known as the centroid. So we're given the shape, and what we're going to do here is we're going to break this shape into smaller shapes where the centroid of those smaller shapes is much easier to find. So let's get started, and this will make more sense as we go along here. So I'll break this into 3 different shapes here. So we have a triangle on this side. I'm going to break this up into a larger square. So we have the square, and then we're going to subtract off this rectangle. So by finding the centroid of all these smaller shapes, we can then use our formulas to find the centroid of the composite shape. All right, so what I like to do is create a table. All right, and the columns on the table are the area. These are x tilde and y tilde represent the centroid of the smaller shapes. Okay, they're not the overall centroid, they're the centroid of the composite shapes that we're adding up. And then we have x tilde times a, where we just take the column x tilde and multiply it by a, and that is going to be in feet cubed for what we have here. And then also y tilde times a here, which is also going to be in feet cubed. And the shapes are shown up here, the triangle 1, square 2, and the rectangle 3. So let's get started. Shape 1, we have this triangle here. And we know that the area of a triangle is 1/2 base times height. So that's 1/2 times the base, which is 3. And the height here is also 3. So we're looking at 4.5 there. So that's 4.5 feet squared for the triangle. X tilde is the distance away, and you can see the origin here. And remember, in a triangle, this is the distance that the centroid is away is 1/3 the base. So if the base is 3 feet, we know x tilde here is 1. And likewise for y tilde, that's the distance and the y-axis here. That distance is also 1/3 of the base, which is 3. 1/3 of this distance, I guess, 1/3 of the height, which is 3. 1/3 of that is 1. Okay, so x tilde times a, we have 4.5. And then y tilde times a, we also have 4.5. Okay, moving on to shape 2. And remember that this shape is the big square here. And so for a square, it's just the side lengths squared. And so we have 3 squared, and that comes out to be 9. X tilde is halfway, so if the whole base here is 3, it's half of that, and that's 1.5, but we must make sure it's negative, right? It's in the negative x direction if this point in the center is 0. So that's negative 1.5. And then y bar is positive 1.5. So x tilde times 9, that comes out to be negative 13.5. And y tilde times a. Y tilde times a here is 13.5 as well. This one's positive. Okay, and the last one, we need to make sure that we're subtracting. All right, so let's make sure that we're subtracting here. All right, so this has got to be a negative number. So don't forget the negative if you're subtracting areas here. So what that comes out to be for this rectangle is 2 times 1, and that is 2. So let's put negative 2 there. Let's make sure that's negative. And x tilde here, it's over this direction. So we have to have 2 plus another half foot. So in the x tilde is negative 2.5. Negative 2.5. Yeah, and y here, the distance, the center is here, that's half of 2, which is 1, plus another 1 here, which is 2. All right, so x tilde times a. So we have negative 2.5 times negative 2. So this is going to be a positive 5 here. And 2 times negative 2, that's going to be negative 4. Okay, just a note, we didn't have to draw this as a subtraction here. I just wanted to show you that you can use subtraction when finding the centroid. You could have broken this into a small square and a rectangle here without using subtraction. But let's keep going with our example. And so we want to find the sum of the areas, and then the sum of x tilde times a, and the sum of y tilde times a. Because our centroid formulas, x bar being the centroid, we have the summation of x tilde times a divided by the sum of the areas. And then for y bar, we have the same sort of formula, except the y's are substituted in there, sum of a. So, okay, let's do this. So the sum of x tilde times a, so we add all these up together, and it looks like that comes out to -4 if we add all these together. And we divide it by the total area, and the area came out to 11.5 feet squared. So we divide that by 11.5 here. And that comes out to be x bar, our centroid in the x direction, is -0.348 feet. Okay. And for a y direction here, we have y tilde times a. That comes out, the summation of this column is 14. And then we divide it by the area, which is 11.5. And that comes out to be 1.22 feet. So let's go back and make sure this makes sense. This is our answer here for x bar and y bar. Let's make sure that this makes sense. So we have x is -0.348, which is somewhere in this area. And then y is 1.22. So we're looking that this is roughly, probably right, the overall centroid. This is x bar, y bar. The center of the area is this location here, which makes sense, So that's a quick example on how to do a centroid of a composite area.